Good morning. Welcome to Mission Control Houston, where you're getting a live look at the International Space Station's lead flight control team on console. Teams monitoring the health of the station's systems and assisting the Expedition 56 crew members as they press through their day's agenda, tending to station maintenance and operations tasks, and assisting with the scientific research underway in the station's laboratory modules. Commander Drew Feustel and his crewmates are also getting ready for some special operations on their schedule on Monday morning, when they will greet and grapple a commercial cargo ship that started its supply run with a launch from Florida early this morning.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Leah Cheshire. A spacecraft carrying new science experiments, crew supplies, and hardware is on its way to the International Space Station. The SpaceX Falcon 9 rocket lit up the sky as it blasted off for a 3-day Earth orbit, marking SpaceX's 15th commercial resupply mission. The SpaceX Dragon will rendezvous with the space station on Monday, July 2nd, when NASA astronaut Ricky Arnold will use the Canadarm2 to grapple the spacecraft in preparation for remote installation by the ground crew. The Dragon spacecraft, loaded with nearly 6,000 pounds of supplies and experiments, will remain at the International Space Station for 32 days before undocking and returning to Earth, bringing completed experiments along for further analysis. Thanks to the upcoming arrival of the SpaceX Dragon, the crew is going to be very busy working on the new science experiments it brings. One of these experiments is the EcoStress device, which will manage the temperature of plants to help us better understand how much water they need and how they respond to stress. This is critical as we prepare for long-duration space missions to the Moon or Mars, as astronauts will need to grow their own food aboard the spacecraft. However, experiments like EcoStress have applications to life on the ground, too. Ecosystem productivity is threatened by water stress, which EcoStress can help detect and analyze. This may help inform future agricultural plans and water resource management on Earth. This week's question comes from Monica, who wants to know if astronauts experience vertigo while in orbit. Upon their arrival to the space station, some astronauts do experience space sickness, which includes symptoms like vertigo, mild headaches, and nausea. Space sickness occurs as the body tries to acclimate to a microgravity environment. Sensors in the inner ear, which are part of the body's vestibular system, can sense the pull of gravity on Earth. In space, however, the body must adjust to the lack of gravity. There is no up or down. This confuses the brain, but fortunately, most astronauts adapt rather quickly. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
Off the Earth, for the Earth. Space to Ground.
Leah mentioned the EcoStress experiment, which is part of the almost 3 tons of cargo now on its way to the International Space Station. Here's a quick look at that and some of the other payloads on board the Dragon cargo ship that has an ETA of Monday morning. This Dragon cargo ship is on a 3-day transit to the space station. NASA TV and NASA.gov will have live coverage of its arrival on Monday morning, starting at 4:30 Central Time Monday morning, for coverage of rendezvous and capture. Capture with the station's robotic arm is expected at 6 o'clock Houston time, and will be back on the air at 8 a.m. Central for coverage of installation of the Dragon ship to the Earth-facing port of the Harmony module. Feustel and his crewmates will spend time next week unloading the Dragon ship and stowing its contents all around the station, which is no small task. The International Space Station has more internal space than a six-bedroom house contained within a vehicle large enough that it would cover an American football field. How long does it take to get a tour? Well, not as long as you might think. In this Speedy Time feature, astronaut Jack Fisher flies us through the station from bow to stern in just 3 minutes and 18 seconds.
Today we're going to take a tour of the incredible place we get to call home, the International Space Station. We're starting in the JLP, which is one of our mini closets for stowage. Then we're coming in to the Japanese segment. We have lots of experiments. We have huge freezers that you've seen. Then we have a node where we can dock modules in 3 different directions. We have the European module called the Columbus. It has tons of scientific equipment as well. This thing is called Mares. It's one of the biggest things on the station. All right, let's check out the United States Laboratory. But first, we'll see where we sleep. This is node 2. We watch our movies here, and we sleep here. This is where I sleep. It's pretty messy, but at least there's a flag. That's cool. In here is the United States Laboratory, the Destiny. We have tons of equipment in here, not only scientific equipment to look at different experiments, but also some of the systems that really keep the space station going. So that's pretty cool. We also, in here, have node 1. We can dock more vehicles here at the docking port. On the bottom, it gets kind of confusing what's up and down. In here, we have the airlock. This is where we get into our spacesuits in this room, and then we go into this little room, and we close the door, we take all the air out, and we go outside and do spacewalks. Very cool. Over here, we have our treadmill, which you have seen before. Right here, we have our toilet, the super space toilet, or outhouse, as we lovingly call it. We have the ARED, which you've seen before from Peggy's video. This is the PMM, where we store a ton of stuff. And then, of course, everyone's favorite, the cupola. If we come down here, you can see outside, and it's gorgeous. It's just so pretty. It never gets old. Okay, let's check out the Russian segment. Come on, here we go. We're going through the little hatchway that takes you into the Russian segment. Inside the Russian segment, there's lots of modules as well. Down here is Mimadin. This is one of the many places where we dock vehicles. This is where Peggy actually docked. This is the FKB. This is another place where we keep a lot of our storage. It also has some of the critical systems for the Russian segment. Over here, we can go one of 2 directions, and it sometimes gets confusing. Let's see where we're going home. This is Mim Deva. We have an extra spacesuit, and we have our spaceship, the beloved Argo. So you can see we have 3 little pigs in a blanket with our spacesuits, and then this is our actual Spuskaymy apparat. That's what we sit in, and that's the part that we actually land in. This part actually burns up in the atmosphere. Okay, let's check out the heart and soul of the Russian segment, the service module. Obviously, the service module holds lots of critical systems for the Russian segment, but also for the space station, like our engines, to reboost and get to a higher orbit if something's about to hit us. One of the cool things that's in the Russian segment is the Russian cosmonauts, like Fyodor, our commander. In the Russian segment, we have tons of great windows. These are really high-quality windows, so we can take pictures. We also have a lot of systems that keep the station going, and we have another cargo vehicle at the very end of the station. And the last thing I'm going to show you is my favorite space picture because of what it represents. This is Yuri Gagarin with a dove, because space is a peaceful exploration where we work together. If you notice, I got a Russian shirt, I got American socks. It's international. That's what this place is about, working together as one team. Woo! That's Speedy Time this week. Have a good day.
Those laboratories that Fisher just flew through, they're home to dozens of experiments that are taking advantage of the absence of gravity to learn more about the physics of things on Earth, because removing gravity from the equation allows scientists to learn more about why things act as they do when gravity is present. During this year of education on station, the NASA astronauts are also doing experiments for the benefits of school students on Earth to help them learn in their studies of science, technology, engineering, and math. This week, flight engineer Ricky Arnold added a new demonstration video that gives us a unique look at how the molecules that make up water behave in space.
Welcome to the International Space Station. I'm NASA astronaut Ricky Arnold. Our view from the ISS of Earth is absolutely magnificent, but we quickly realized we really should call it Planet Ocean. We are mostly a water planet. Water occurs here in all three phases, solid, liquid, and gas. And the presence of water on other planets and moons within our own solar system has us wondering, is there life there too? Well, why is water so special? One reason is called surface tension. So what is surface tension? Let's have a look. Surface tension is a property of liquids in which molecules of one substance are more attracted to each other than to molecules of another substance. Water is unique in that it has a high surface tension compared to other liquids. This is due to its polar property. The positive hydrogen ends and the negative oxygen ends create a strong bond. As they say, opposites attract. So the hydrogen end of the water tends to stick to the oxygen end in a nearby water molecule. At water's surface, its molecules are only attracted to the water molecules below and to the sides of them, as there is only air above these molecules. So the surface molecules of a body of water are pulled down, creating a more stable, stronger environment. That is why certain animals, like the water strider, can actually walk on the surface of water. Here on the International Space Station, the microgravity environment makes it easy to show how well water uses surface tension to stick together. We even rely on surface tension to help us wash our hair, those of us that have a lot. Thanks for coming along today and learning a little bit about surface tension. Want to learn more about the unique properties of water and do your own experiments? Try out the activity related to this video at the STEMonstrations website. See you next time.
Research in physics and outreach efforts in education are just part of the science mission on the International Space Station. There are experiments underway in many disciplines, including human life sciences, plant biology, technology development, and more. Now, one thing that all of these experiments have in common is that they're taking advantage of a condition on the station that can't be replicated anywhere on Earth: microgravity.
An out-of-this-world research lab. Presented by Science at NASA. Every now and then when the sun sets, a bright light appears on the western horizon. Gliding silently overhead, it is the biggest spacecraft ever built by humankind, the International Space Station, or ISS, carrying a precious cargo of astronauts around Earth. But the ISS is more than just a bright light in the night sky. It is also an out-of-this-world research laboratory. The interior of the ISS is furnished with laboratory equipment and chambers for experimental research. It's not as large as some Earth labs, but it has one thing that Earth labs do not: microgravity. Gravity influences everything that happens on Earth. It's hard to envision what life would be like without this force. Yet removing the pull of gravity can be uniquely instructive. Reduced gravity provided by the ISS is a major attraction for researchers, says Joseph Nugget of NASA's Johnson Space Center in Houston, Texas. The weightless environment allows scientists to gain insight into basic phenomena in many fields. For example, says Nugget, we all have seen that roots of plants grow down into the earth. Is this because of gravity? Experiments with plants on the ISS can tell us. Understanding how roots grow is directly applicable to space exploration. What does NASA need to consider when designing a plant chamber for food or life support in space? Farmers on Earth are interested too. A deep understanding of roots can help scientists design hydroponic chambers for agriculture in areas with poor soil conditions. Since the first modules of the ISS were launched in 1998, up until 2017, more than 2,400 investigations have been undertaken by over 3,400 researchers in over 100 countries. Astronauts have spent more than 36,000 hours helping run the experiments for scientists back on Earth. To date, more than 1,600 scientific journal and magazine articles have been published reporting the results. It's a scientific bonanza. There are 5 major research areas on the ISS: biological sciences, such as the root experiments; physical sciences; space science and fundamental physics; human research; and earth science. Nugget has favored examples of each. Scientists grow crystals on the station to discover new crystalline forms. Protein crystals grown in small chambers on the station reveal information that helps find new, novel ways to combat disease. The space station is also equipped with furnaces that can melt solid metals and alloys. This can reveal the metal's crystalline structure in a new way and give greater insight into the properties of the material. While protein crystals are a biological science and metal solidification is a physical science, both are examples of how crystalline structure develops in microgravity differently than on Earth. Switching over to fundamental physics, he says, there are several investigations on the ISS that examine fundamental laws of physics and continue the search for theoretical particles. The alpha magnetic spectrometer, for instance, provides valuable data on the existence of dark matter. Human research is also very interesting and dynamic, helping NASA get astronauts ready for deep space exploration with many spin-off benefits for people on Earth. Nugget notes, research like the lighting effect study helps improve our flight team's productivity on the ISS and on the ground here in Mission Control, as well as the many American workers who work on night shift or alternating shifts. One-year missions to the ISS return much information about how the human body adapts to space travel, from the genetic level to how the astronaut deals with the long-term isolation within the spacecraft. Not all research conducted on ISS requires reduced gravity, he notes. For example, the ISS is a great place to observe the Earth. The station passes over the vast majority of the Earth's populated areas. Sensors and cameras on the ISS can contribute to disaster assistance, tracking hurricanes, measuring wind and rainfall, as well as documenting events such as volcanic activity. The ISS, much more than just a bright light in the night, indeed. For more from the International Space Station, visit www.nasa.gov/station. For more news about science on and around the Earth, stay tuned to science.nasa.gov.
NASA's Human Research Program is using the International Space Station to learn more about how living in space impacts the human body, so we can figure out how to counteract the negative effects and protect future astronauts when they explore out beyond Earth orbit. That includes dealing with the radiation that astronauts are exposed to when they're outside the protection of Earth's atmosphere. In this installment of a series on space radiation, HRP scientists discuss the biological risks that future astronauts will face on missions out into the solar system.
So of all the things that the Human Research Program is investigating, the biological consequences of radiation exposure is one of the major ones. Some of the reasons for that is that the health consequences following radiation exposure are very complex processes. It's difficult to quantify exactly how the radiation is interacting with tissue, and then it's even more complicated to try to quantify and determine what the long-term outcomes are going to be in terms of things like carcinogenesis, central nervous system effects, and detriment to the central nervous system.
The primary means by which radiation affects cells is by damaging their DNA. You can get breaks in the strands in the double helix, you can knock bases out, and the cell will make an attempt to repair that damage. Sometimes it's effective, sometimes it's not, and sometimes it'll actually get repaired, but in an error-prone fashion, so it's what we call misrepaired. So anything that sets into the genome in that way is a mutation, and then the accumulation of mutations can potentially lead to cancer and take a non-cancerous cell, a normal cell, and make it transformed into a cancerous one, so that's a big concern.
So on Earth, there's a couple characteristic things that are different from space. One of them is that the type of radiation we experience on Earth is generally what we refer to as low LET radiation, things like gamma rays and X-rays. We also have the protective shielding of the Earth's magnetic field and the atmosphere, which shields a great deal of the radiation. And then finally, we have things like radiation protection concepts such as time, shielding, and distance. So we can reduce the time of exposure on Earth, we can reduce the distance from the radiation sources, and we can reduce the exposure through shielding. In space, a lot of those things are very different. So we have a very complex radiation field that includes things like protons and all the particles on the periodic table of elements, they're coming in at energies that are approaching the speed of light, and they're difficult to shield against, and they're always there. So the concept of time really doesn't make sense because you can't reduce the exposure in space except perhaps getting to Mars faster. You can't really reduce the distance at all because the radiation is everywhere. And shielding concepts for galactic cosmic rays are very difficult because of the energies involved.
The International Space Station is the site of unparalleled science on orbit, generating benefits for those of us on Earth and helping humans get ready